Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Najmi and we are from Group 2 will be present the line integral in a vector form. Basically, there are two types of line integral. That is line integral over the piecewise smooth curves, and the second is line integral in the vector form. And today we are looking for the presentation line integrals in the vector form. So this is the introduction for line integral in the vector form. And we let C with a smooth curve in a T space in given a parametrically by the equation in terms of T, x equal to xt, y equal to yt, and z equal to zt, and the given range T from A to B. And this is we let the smooth curves. Then we let the f x y z, g x y z, and h x y z be a continuous on some open regions that's containing the curve C. Then we can write line integral along the C in a vector notation as f x y z equal to f x y z I plus g x y z j plus h x y z k. After that, since the curve C given in a parametrically equation, it also can be expressed in terms of position vector, that is rt equal to xti plus ytj plus ztk. After that, work done by a continuous force can be calculated as work equal to integral C fxyz dot dl equal to integral from the A to B f xt yt zt dot of derivative of r, and can also be written by integral of f dot by the its tangential components.
Okay, let F be a vector field that is continuous on a region containing a smooth-oriented curve C parameterized by arc length, and then let T be the unit tangent vector of each point of C consistent with the orientation. And we can look that the formula line integral of F over C is integrate F dot T ds, since ds over dt are equal to modulus r prime t, therefore dt are equal to ds over modulus r prime t. Hence, integrate f dot t ds are equal to integrate f dot r prime t over modulus r prime t ds are equal to integrate f dot r prime t dt. All of students must take note that reversing the orientation of a curve reverse the sign of the line integral of a vector line integral. This figure shows how work done in 3D space and 2D space are working. The application of integral in vector form. In line integral, we integrate at the scalar value function, which is scalar line integral, or vector field, which is vector line integral, along a curve. For the first example of applications, if you want to calculate the amount of work needed to put a satellite into orbit by integrating the gravitational force, which is a vector field, along the curved path of satellite. And for the second example, if you want to compute the average temperature along the edge of a thin and circular plate with a non-temperature along the edge of a thin and circular plate with non-temperature distribution by integrating the temperature function over the curved boundary of the plate. This figure shows the application of line integral in vector form of work done settling into orbit and the average temperature along each thing.
So the first example is find the work done by the force gravitational field F equal to y squared over 2 z and x in moving a satellite along the orbit C, where orbit C is the intersection curve of the plane x plus z equal to 1 and the ellipsoid x squared plus 2y squared plus z squared equal to 1, oriented counterclockwise when viewed from positive z axis. First, for all, we have to write the plane equation is equal x plus z equal to 1. And we have to write the ellipsoid equation x squared plus 2y squared plus z squared equal 1. Then we have to uh, find z is equal to 1 minus x. So we have to put the equation into ellipsoid equation. So we get x squared plus 2y squared plus 1 minus x squared equal to 1. Then we have to complete this equation 1 minus x squared. So we get x squared plus 2y squared plus 1 plus x squared minus 2x equal 1. Then we have to uh, short form it into 2x squared plus 2y squared minus 2x equal to 0. Then we have to factorize 2. So we get x squared plus y squared minus x equal to 0. So then we have to complete this x squared minus x. Then we get x minus 1 over 2 squared plus y squared equal to 1 over 2 squared. So this is the center of the circle. So the center is 1 over 2 at this. Then the y-axis is 0 with radius 1 over 2. So we have to complete 1 over 2 squared. So we get x minus 1 over 2 squared plus y squared equal to 1 over 4. Then we have to transform it into parametric curve. See, so x we get 1 over 2 plus 1 over 2 cos t. Y is equal to 1 over 2 sin t. Then the limit is 0 until 2 pi. So the formula of work done is W equal to integrate F dot dr, which is equal to integrate F RT dot r prime t dt. So we have to write RT, which is equal to 1 over 2 plus 1 over 2 cos t for I, 1 over 2 sin t for j, and 1 over 2 minus 1 over 2 cos t for k. Then we have to integrate, then we have to differentiate it. R prime t is equal to dr over dt, which is equal to minus 1 over 2 sin t for I and 1 over 2 cos t for j and 1 over 2 sin t for k. Then we have to dot it f dot dr. Then we get we have to write it first. So 1 over 2 plus 1 over 2 cos t, 1 over 2 sin t, 1 over 2 minus 1 over 2 cos t dot negative 1 over 2 sin t, 1 over 2 cos t, and 1 over 2 sin t. Then when we calculate it, when we dot this f dot dr, we get negative 1 over 16 sin cube t plus 1 over 4 cos t minus 1 over 4 cos squared t plus 1 over 4 sin t plus 1 over 4 sin t cos t. Then we have to calculate the formula work done given in the first slide. So the formula is integrate f dot dr equal to f integrate f rt dot r prime t dt, which is this f rt dot r prime t we get from this. So we have to insert this solution into this to integrate to calculate the work done. So integrate 0 until 2 pi negative 1 over 16 sine 3t plus 1 over 4 cos t minus 1 over 4 cos squared t plus 1 over 4 sine t and plus 1 over 4 sine t cos t. Then we get negative 1 over 16 integrate 0 until 2 pi sine cube t dt plus 1 over 4 integrate 0 until 2 pi cos t dt minus 1 over 4 integrate 0 until 2 pi cos squared t dt plus 1 over 4 integrate 0 until 2 pi sine t dt plus 1 over 4 integrate 0 until 2 pi sine t cos t dt. Then we use the property which is integrate 0 until 2a fx dx. We can get, or it can be 2. We get from this limit, we take 2 into the front. So we integrate 0 until a fx dx. If the fx is the event function, then we also can get integrate 0 until 2a fx dx equal to 0 if the function is odd equation. So sine is odd function, so we get 0 equals 0 plus 1 over 4 times 2 because cos is a even function. So times 2 integrate 0 until pi. We have to 2 to put in front of the integrate. So we have 1 over 4 times 2 integrate 0 until pi cos t dt minus 1 over 4 times 2 integrate 0 until pi cos squared t dt plus 0 because this is odd function plus 0. Then we have equal to 1 over 2. We have to integrate cos t equals to sine t. Then we input the limit pi 0. Then we have to minus 1 over 4 integrate 0 until 2 until pi 2 cos 2 t dt. So equal to this, we equal to 0. Then this equation we put negative 1 over 4 integrate 0 until pi the identity cos 2t equal to 1 plus cos 2t over 2. So these two we cancel off with the identity over 2. So we have to calculate negative 1 over 4 integrate 0 until pi 1 plus cos 2t dt equal to negative 1 over 4 integrate 0 until pi dt plus integrate 0 until pi cos 2t dt. So we can get negative 1 over 4 t, the limit pi and 0 plus sine 2t over 2. We integrate cos 2t, we can get sine 2t over 2, the limit 0 pi. Then we can get negative 1 over 4. This equation, we insert pi into t minus 0. So we can get pi. Sine to t over 2, we insert pi. We can get 0. Then we insert 0, then we can get 0. So the answer is negative pi over 4.
Assalamualaikum, my name is Luqman Adam Yahya. I'm going to talk about how to find work done by using line integral in vector form. So the question is, find the work done by the force F equal to y minus 2z I plus xyj plus 2xz plus yk that acting on a particle that move along the curve is given by x equals to t, y equals to 2t and z equals to t square minus 1, and the range is from 0 to 1. To find the work done, the first thing we must do is we differentiate the curve given. From the curve given, we can get the parametric equation that we can differentiate it to get the r prime and then put it into the formula. So differentiate x, we got t, differentiate we got 1, y we have 2t, we differentiate we have 2, and z we differentiate t square we got 2t, and then we change it into parametric equation. The next step is we enter the value of curve into the force, and then we get the parametric equation for the force. The next step is we combine the parametric equation by using the formula, and then we integrate from 0 to 1 to get the value of work. That's how we find the work done by force using line integral in vector form. Thank you.